Hi, I'm Pat Kelly. Okay, in this problem, we got a bit of work to do, but let's jump in. This is what they're asking us, is they've given us a general solution, y equals c times parentheses x plus 2 squared. And that's a solution to the differential equation that they've given us here. And our task is to sketch the graphs of the particular solutions that correspond to the values of c that they provided us. So you can see there are 5 values of c. That means we're going to do 5 different graphs, each one representing a different particular solution to this differential equation. Okay? Now, you won't really need this differential equation in our work. That's there for reference. What we need to focus on is that general solution. As we've been working with, the general solution has infinitely many different possibilities, and they're just differentiated by those values of c. So they're giving us specific values of c and asking us to sketch that graph. So the first value they give us is 0. So the general solution here, I'm going to put a 0 in for c. So I'll have y equals 0, parentheses x plus 2 squared. And I'm supposed to graph that, but I would definitely do a little bit of algebra first, because that simplifies to y equals 0. So to graph that, I would graph y equals 0. That's an easy line to draw. Next one I'm supposed to draw is corresponding to c equals 1. So I'll go back to that same reference point of the general solution, but put in the specific value of 1 for c. So y equals 1, parentheses x plus 2 squared. Not too much simplification there, unless you just want to get rid of that coefficient out in front of the parentheses. So the challenge then is to graph it. This, I hope, obviously is a parabola. Okay, so we have that 2 power, but we have the plus 2 on the inside of parentheses. This takes you back to your shifts and translations and stretches that you should have learned. The plus 2 inside parentheses just means that we shift the vertex over to the left 2. And then the parabola I'm about to draw, opening upward because the coefficient of x squared is 1. So I'm going to draw the parabola opening upward, and for a quick reference point, think about 0. If I put a 0 in, 0 plus 2, but squared is 4, so 0, 4 would be a point. And then I can give at least somewhat of an accurate drawing with my parabola, like that. Okay, moving on, it's just a different value of c, but the same thought process. I go to the original general solution, putting in a -1 for c, x plus 2, parentheses squared. And all that does for me is give me a negative sign outside of the parentheses. Thinking back to the shifts and translations lessons from so long ago, that just reflects it through the x-axis. So I again have that shift to the left, 2 units. It's going to be my vertex. And it's again a parabola, but this time opening downward because of that multiplication by a negative. So I might get another quick reference point. 0 in for x, 0 plus 2 squared, 4, but negative. So 1, 2, 3, 4, 0 minus 4. This to give me somewhat of an accurate parabola, and pretend that's a nice smooth curve right there. Next one over, they give me a value of c equals 2, y equals 2x plus 2, parentheses squared. Keeping in mind each time I'm just going back to the original general solution, putting in a specific value for c, and now thinking about what that does to the graph. To the left 2. The 2 coefficient in front, it's one of those stretching factors. So you might remember that that stretches the basic parabola. But I would give myself another reference point by thinking of plugging in a 0 again. 0 plus 2 squared is 4, but multiplied by 2 gets me all the way up to 8. So then I'm trying to draw the parabola like that. Again, pretend that's a nice smooth curve. Finally, c equals -2 is just going to give me this parabola. Shifted 2 to the left. -2, it's stretched. Negative going down, so I'm going to go down to -8. That's me putting a 0 in for x again. 0, -8, and doing my best to draw a parabola. Okay, so for this problem, they give us the general solution. They give us some specific values for c. They ask us to graph each of them. And one of the reasons we do this is that you can see relationships between all of these different infinitely many general solutions. C could be anything, infinitely many different choices, but they pretty much all take on the same shape, with the exception of C equaling 0. That's what we call a degenerate case, which sounds mean. If you want to insult it a little bit, hey, you're degenerate. But other than that, all of them look like parabolas, just moved around a little bit or stretched a little bit. Okay, hopefully that helps.